First time ever saying this out loud anywhere. I've got a new company called TrueField Systems, and we're working on a small harvester.
Wow,
Yeah.
I don't know that we've ever launched a company on the podcast. Hey there, and welcome to Manufacturing Mavericks from TBGA. I'm John Barnes, founder of the Barnes Global Advisors and Metal Powder Works. I'm a materials engineer, a girl dad, and a key stakeholder of two golden retrievers. I'm glad you're joining us. Each episode, we shine a spotlight on the people pushing the boundaries of advanced manufacturing. We explore the edge of technology, dive into economic issues, trends, the critical ideas driving manufacturing forward, with a special emphasis on the exciting world of additive and advanced manufacturing. We look at new tech breakthroughs, industry trends, and my favorite, process economics. But we know there's more to work than just work, so we dig into leadership stories, life lessons, and the quirks that make this field fun. And yes, you can count on some dad jokes and some puns along the way because what's a show without a little groaning? Thanks for tuning in. Let's get into it. Joining me today is Scott Bledsoe, founder and inventor. I met Scott after I stopped mid-run one day listening to the Merge podcast about the Fury unmanned fighter aircraft. He is a experienced aerospace executive with proven skills in building high-performing teams, rapid development of unique and difficult aircraft configurations, operations growth, bringing innovation to the DoD, and interestingly, implementation of quality management systems do not soul crush company culture. So thanks for joining us, Scott.
Oh, you're welcome. Glad to be here, John.
Hey, did you know that they found a dog floating in the ocean?
No, I did not know that.
He was a good boy.
Oh, okay. Yeah. I'm sure
Yeah.
there'll be more groaning at it in post. Hey, I've got
Yeah.
one. I've got one for you actually.
Oh, okay.
And I got this one from AFRL. So maybe we'll talk about AFRL more later. But somebody at AFRL asked me, how do you know when a regular joke becomes a dad joke?
It becomes apparent.
Ah, you know that one. Okay, all right. That one was new to me. I thought it was pretty good. All
Yeah,
right.
it is a good one. Yeah, so you've had a very interesting career, and I think for our listening audience, like I was no joke, I was listening to the Merge podcast, which if you don't listen to the Merge podcast and you're remotely interested in defense and related stuff, I highly recommend it. You and your co-founder were on talking about a variety of topics, color of money, how the Fury came into existence, how it ended up at Anduril,
Yeah.
and it's pretty fascinating. I found because it helped like in a very short period of time, you covered a lot of topics, like you covered a lot of
Right.
space, but you kind of hit on some relatively complex things. I felt like a good way. And I was on a run and I literally stopped and tried to friend you on LinkedIn, which I don't normally do, mind
Yep.
you. That was a first. And
I'm honored. Thank you.
so I was like, oh, this guy's going to think I'm a freak. So I appreciate, getting to this point. So we've had a couple chats now. I
Hmm.
think it's also interesting, like we're about the same age. We have
Hmm.
parallel experiences, I think, overall, not carbon copies by any stretch,
Yeah.
but maybe later on we'll get into what we're talking about here. And I don't know whether there's anything to that or not. This is where I sort of put my psychologist hat on.
Well, we
But,
were both doing aerospace before it became cool. That's one
well,
thing.
that's true. Yeah.
It's
Well,
really cool now.
aerospace, yeah.
It's having a moment now. I think
Having a moment.
I think we both started in a little bit of a lull, kind of late Cold War, and it wasn't cool for a couple of decades, and then it became cool in the last decade. So
Yeah. Well, I know for me, like I always wanted to be a pilot and I
yeah,
was
me
going to be
too.
a naval aviator. And then Top Gun came along and I was like,
Yeah.
100% that's going to be me. And then I read about engineering and I read about materials engineering and how that was limiting these aircraft designs.
Hmm.
So that's how I got into it. But you got your bachelor's in aerospace from NC State and you started out with NavAir. So you actually got to go work on these things. And I think you worked on the Harrier.
That's right. Yeah, I went to work for the government right out of school. And when I graduated in '94, there was a little bit of a recession going on,
Yeah.
especially like I think a month before I started sending resumes out, Boeing laid off like 10,000 people or something. So it really seemed like a rough time, and it was a rough time. But yeah, scrambled and found a job with Navier at Cherry Point, and I was working on the Harrier. So it was depot structural repair work that I was doing. And, I like to tell people the Harrier was a fantastic airplane to learn how to be a structural engineer on because it's partly composite, it's partly metal. It was partly made in the UK with, their names for their alloys and their type of primer. and partly made in the US and good old St. Louis. And then of course the composite bits, I believe they were mostly made in St. Louis, autoclave composites, sort of old school, 350 curing systems that were very finicky. And as an aircraft, it has all of the problems of helicopters and all of the problems of fighters that pull 7Gs. So low cycle fatigue, high cycle fatigue, acoustic fatigue. So it was great for me as a young engineer. I don't know that it was that great, for the owners for the Marine Corps, but it certainly created a novel capability, and it paved the way to the F-35B.
Yeah, and that had a similar experience, not the same as the Harrier, but there was a work stoppage at Lockheed Martin one year, and a lot of the engineers went to go fill in the lines as an aircraft
Yeah.
mechanic. So I got to learn how to drill holes for 2 weeks. It's a lot harder to do it
Yes.
right, and especially in composites. And now I didn't love composites, and I really hated them after I had to drill holes in them. All of the engineers learned a heck of a lot in a very short period of time. So all these things that we had specified, we are now having to do, and
It,
uh, and we were like, well, we're not going to do that again.
Yeah, isn't that the truth? I remember doing a repair one time. So after Cherry Point, I went to work over in Naples, Italy, still for the U.S. Navy, and there we would go all over and do repairs. But I remember working on a an EA6B that had a bird strike, and we were replacing the inlet skins. And the inlet skins are riveted in with what are called icebox rivets. Are you familiar with icebox
Hmm.
rivets? Yeah. So, you basically are heat treating the rivet and then you're taking it out and you need to put it on dry ice. And I think with dry ice, you have like 24 hours to use it. We didn't have dry ice. So we were in Turkey at a Turkish Air Force base. We found a heat treat oven across town, and like literally the Navy guy working with me, was driving like 90 miles an hour after getting these things out of the furnace before they cool off and harden, because you have to buck them in about an hour, otherwise they're impossible to buck. And so yeah, guy gets a speeding ticket in Turkey. I don't know if he paid it, but just but you don't think about these things, right? When you call it out on the drawing, it's just a two letter code on a drawing, and you don't think about what it means to call out some of these processes. So absolutely, I agree with you. Every engineer needs to get out in the shop sometimes.
So you went from that experience. So you got, let's say got your hands dirty, let's say, and somewhere along the line you crossed over from engineer to project engineer and engineering manager, much like I did. Was that an intentional thing, or is that just something that you kind of like I
I
did? I
think
just stumbled into it.
Yeah, I think I just stumbled into it. I think, and this is kind of a lesson for younger engineers. I mean, eventually you will probably find yourself, if you're good at managing yourself, you'll get more and more responsibility, right? So if you're good at planning a project or planning whatever scale of activity you're doing as a first year, second year, third year engineer, you'll get trusted with more responsibility. And inevitably you're going to end up at the boundary with another discipline, right? So and that to me is where all the really interesting stuff happens. I never wanted to be one of these people who was hyper specialized. Now, some people aren't. Some people are really good at it. They go on to become, tech fellows, senior scientists at companies. But there's a lot of good work you can do by sort of learning how to meet the other discipline in the middle. And so, yeah, I highly recommend that you think about that as you start your career.
I think I moved into project engineering and then program management from there. And one of the saying that you hear all the time is them that holds the gold makes the rules. And I
That's
found
right.
that provided us a good amount of security because I could then make the decision about where effort or resources needed to be placed. And then I think so not many people probably know this company. Like if you've been in the industry before it was cool, you would Scaled Composites.
Right.
How did you get to there? And was that as cool as I imagined it to be?
Yes, it probably was. I think you know a little bit about scale, but yeah, I'll say that it is every bit what you could imagine. So I actually applied there coming right out of school. They didn't typically take people right out of school, and true to form, they didn't take me. And I'll say that, hey, just luckily after I was through working for the Navy, I had a security clearance and they had some work that required a clearance. So, I joke that, they lowered their technical standards for me because I had a clearance in place and it can take
Because
a
you could be
year.
trusted.
If yeah, I could, well, if you don't have a clearance, it can take a year, right? So, I think once I got on board, I proved my worth, but it was an amazing place. If you're not familiar with it, go look it up. I highly encourage you to go find, I think it's on YouTube. There's a documentary called Black Sky, which was about the Spaceship One program. And sadly, one of the guys featured in there, Mike Melville, just passed away in the last week.
Mm.
But it covers the first privately funded manned space program. So it was a suborbital space vehicle. It won the X Prize. I mean, sadly, now in 2026, I run into people who don't know what the X Prize was and how important that
Hmm.
was. But I mean, John, you'll remember at the time that that was the most interesting thing going on in aerospace. And at a time when we were putting people into suborbital space, NASA had no capability to put astronauts in space because of the Columbia disaster. So it was a really interesting time. It was an interesting time to show that a private company could do amazing stuff. And at the same time, we were doing Spaceship One, which I was not a part of that program. I was running a defense program. So we had a significant defense program going on. We were working on an airplane that flew around the world unrefueled, single
Yeah.
pilot, right? We called it Capricorn. It was the Global Flyer. So Steve Fawcett, another gentleman who should rest in peace, was the project sponsor and the pilot on that. And so we had about a 130 person company at the time I got there, and we were working on all these major significant programs. And I learned a lot about that I applied when I started my own business. And maybe we'll get into that later. But yeah, if you're not familiar with Burt Rutan, if you're not familiar with scaled composites, you owe it to yourself to go look it up.
It kind of reminded me, later on, I'd watched a movie of what it was like for back in like the 50s, 40s and 50s, and the relationship that Lockheed and the other airplane manufacturers had with the airlines. It was more of a camaraderie environment. And then from my experience dealing with some of the people in Palmdale, with Scaled being up the road, they all knew each other. That
Yeah,
was, and I
yeah.
thought, oh, they'd be intensely competitive, but not really. There was, I won't say an open door policy, but I mean, it was a bit more of a brethren than sort of cutthroat
Yeah.
competitor view.
Yeah, I think at that time in aerospace, I think, we're all battling with the same physics. And, this is sort of right after the Cold War. So I think there's still the mentality of we're helping preserve our country's freedom through deterrence. And we're battling physics, right? So there's a natural camaraderie, even though we worked for different companies. I think some of that has gone now, with kind of the arrival of VC money in aerospace over the last decade. So not quite the same as it used to be. But yeah, totally agree with you. If you were in Palmdale in the 90s and early 2000s, it was a pretty special time to be there.
And so this is where we were having a conversation about this earlier, and composites were very, I would say, wildly popular during this period of time. As I would say then, still do. I remember my wife came to me, she's like, what do you know about composites? And I said, oh, well, what do you mean? She goes, well, I've heard it's the material of the future. And I was like, oh, yeah, well, it always will be.
Yes.
So,
Yeah. I'm always suspicious when somebody introduces themselves as a composites expert, because it really is a very multifaceted set of material systems. And so, yeah, but it's really fascinating. I don't know if you want to go in that direction now and talk composites.
yeah, I think, my experience was like I appreciated the material science piece of it, but
Yeah.
really it taught me a lot about mechanics,
Hmm.
design, and almost, fracture mechanics or damage tolerance, and when to use it and when not to use it. But what I learned, and I think we talked about this, is the reason why we use composites isn't always for the same reason.
Right.
It isn't always lighter weight. Sometimes it is the faster solution or it does other things. And I think that was kind of where we started this conversation. And then
Yeah.
then you get into the unspoken tooling word, and then
Yeah.
everybody's head
Well,
explodes.
yeah, that is really where scaled composites, yeah, my understanding of the business model, and it's in the name, right? Scaled composites, meaning if you want to build and demonstrate an aircraft quickly, we can do it often at a subscale size using soft tooling and using, composites, especially at that time, wet layup. At the time the company was started, it was a lot of the moldless construction from the Long Easy, and then moving into soft tooling with wet layup techniques used on that. And so the idea was, yeah, it'll be a little bit heavier, but we can build you something really quickly. It will not meet FAA certification requirements. It'll be a part 21 191 experimental, but we can get you down the road really quickly. Because if you're not familiar with aerospace, the OML, the outer mold line, the outer shape of the aircraft is always in doubt to some point, right? We do our best. We do CFD, we do wind tunnel models. Wind tunnel models have their own problems because of the scale, and the aerodynamics does not completely scale down to tunnel size. So there's things called Reynolds numbers and there's compressibility. So we do our best, right? And then it's time to go fly it. But, in order to make the leap to production tooling, you could spend $1 billion today on
Hmm.
production tooling. And John, you're closer to this than me. You may spend more than $1 billion. So what if I'm not sure that this OML shape is correct, or if I would want to tweak it? That's where it's really attractive if somebody says, "Hey, I can build that plane in less than a year on soft tooling. Your tooling investment will be, maybe $1 million instead of $1 billion, and you get a lot of R&D done. And then once that is demonstrated at full scale or mostly full scale, you can go commit to hard tooling." And that's really, I think, where scaled composites added a lot of value. There were pluses and minuses to that business model, but and then when I started Blue Force, I tried to keep the pluses and ditch the minuses.
That was my learning at Lockheed Martin as well, which was there was a major airlift program. I won't
Hmm.
mention the name, but when I went and did a case study on that for future airlift stuff, they spent $1 billion before they ever made a part. Like the,
Yeah.
it
Yeah.
like no kidding, $1 billion, and that was in 1980s and $90. So you can imagine what it was. But with Skunk Works, a lot of times just some of these programs were hot, and if you couldn't
Hmm.
make 100 of something in less than a year, then the need disappeared. So
Yeah.
this was a competitive advantage to be able to just generate something. The shape, that's where I got to, which was the shape of things, which is the thing we all like to look at. But then at some point, it's what are you stuffing the shape with, which is actually the important stuff. And that's probably what's changed in our lifetimes, where, it was about the pilot, and then it became definitely not about the pilot, not about the
Right.
aerodynamics necessarily, going from making an F-117 fly to then once you've done that, you can make anything fly.
Yeah.
Uh,
I was going to say, yeah, in aerospace, we talked about the importance of the OML. I think the other important thing is, and it's obvious until you bump your head on it, everything has to fit inside the airplane that needs to be in the airplane. And so often, if you don't model the systems well, if you don't do a space claim for hydraulic actuators, or landing gear is a notorious one, right? Like, you don't want to wait to find a home for the landing gear later. And if you
mhm,
can't fit it all in, the design doesn't close. So the airplane has to simultaneously, obviously be able to support its own weight. It has to be able to fly as far as you think it needs to, carrying the fuel. And so, up front, there's a lot of basically sizing equations that have to get solved simultaneously with a reasonable degree of certainty. And, before you commit billions of dollars to a program, it's really nice to build it at a subscale, make sure, you just learn so much. And so, yeah, I think this is where scaled composites kind of cut our teeth. Now, inevitably, when you become successful at that, people want, to your point about skunkworks, people will want a few more, right? So if I'm building one thing that worked really well, maybe my ultimate market is 5 or 10. So I'm still in that same conundrum where I'm not going to hard tool it because I'm not building 1,000. Scaled, we kind of bumped our heads on that because we sort of had a culture of not being a slave to process. We thought that process interfered with creativity.
mhm.
And therefore, we tended to not write stuff down very well the first time we built something. And then when we went to build it the second time, guess what? We hadn't advanced up the learning curve at all. And, darn it, we bumped our heads again. And so, when I set out to create Blue Force, I wanted to be able to capture that repeat business market, knowing that we weren't going to compete with Spirit Aerospace for 1,000 aircraft, but we could darn sure carry our own weight in the sort of 1 to 100 volume. And so that led us, first of all, like culturally, the way we set up the company, we remained project focused, just like Scaled Composites was. So we didn't have like departments at Blue Force. I would never let people use the word department. We had project teams. And if you're an engineer, you're on one project team today, you're going to get moved to another one, in a year or whatever. Same thing with the shop. So we didn't have these like standing departments. The other important thing that came out of that was the recognition that we need to go get a quality management system in place as a small business. And yeah, so that was really important to our success.
I've never heard somebody say that QMS was was really important to their success. So we'll dig into that. But I think along the way so you went from scaled to
Hmm.
Gulfstream before starting your own business.
Yeah.
How did that
So
ladder?
So there's actually one step in between there, and I don't know if it's on LinkedIn or not, but I went to Icon Aircraft for about a year and a half. So that was the light sport aircraft, and it was really cool. It was a fun project because, as much as I liked scaled, I didn't get to work the full life cycle of an aircraft at scaled.
Hmm.
I tended to come in kind of halfway through when the program was kind of like in the dark doldrums, and I was kind of like the guy who would help kind of run it responsibly the second half after the customer was pissed about our performance and things like that. So after doing 4 or 5 of those in 5 years, I was kind of ready to just jump in at the beginning and do a clean sheet airplane and kind of avoid some of the mistakes that I was having to fix. And so myself and a couple other guys went to Icon, and we helped build the prototype aircraft. We did that in 6 months, and it was I would not wish it on anybody. It was a brutal experience, but we had to make Oshkosh in 2008 in order to kind of keep the company afloat. But I went through the sort of standard, I would say, burnout of being at a mismanaged startup where everything is always a crisis and everything always requires heroic activity.
Hmm.
And my wife, you talked about being a girl dad. I had 2 daughters at the time, on my way to 3 daughters. And so my wife and I, started looking around like, hey, let's move back to the East Coast where family is. And Gulfstream kind of popped up on my radar because they were working on a demonstrator for supersonic business jet. And so I was able to pretty quickly jump into that team and go to Gulfstream.
Yeah. And so that was that in Savannah?
That was in Savannah. And, I'll say Gulfstream, it's an amazing company. I think in a lot of ways it was the best run company I was ever at. Maybe aside from Blue Force, I'm biased there, but I really learned a lot about how to. It was a much more, I would say, genteel, take care of people kind of culture. Maybe it's
Hmm.
partly, living in the South, and it's partly just a very close knit community. We were kind of the only aerospace company in town, and so it was a great place. I will say that I think they're a little bit shackled by the fact that they make great products, right? It is the aspirational product of anybody is to buy a Gulfstream business jet, right? But I think that did present challenges when we were on R&D programs. And so I was entirely on an R&D program. I would have a hard time pulling in resources, technicians to work on my projects, because if you can make 20% margin on a 50 plus $1 million business jet, why would you pull a technician off of that and put him on this R&D thing? So I kind of realized during that time that being an outsourced R&D shop, kind of like Scaled Composites was a good business model. But again, I wanted to combine it with being able to pivot to production, which is something that I don't typically.
Hmm.
Small businesses, you just lean into the we go fast thing, right? And I wanted to lean into we go fast, but we do it really well and we can repeat it, but we're not the cheapest. That was kind of our lane.
Yeah. So I can now the path has become clear to
Yeah.
Blue Force. So at some point you convinced your wife or your wife convinced you to go do this other thing.
Yeah, I think I convinced her, and to her credit, she went along with it. I'd sort of seen the, I would say, quick and dirty prototyping model at Scaled Composites, and I had seen the incredibly exquisite product model of Gulfstream, and I really was trying hard to marry both of those and create a capability. And I finally I talked about that enough that I think she said, like, just shut up and go do it. Now, one wrinkle was she was like 3 months pregnant when I quit to start the business. So, that was definitely, I don't always recommend that approach, but yeah, that made for some exciting times. Actually, just to give a real quick story, we were making our first part for Boeing, and this thing's in the oven, and my oven was brand new, and I did not have a controller on the oven that could do anything other than the set point. So I needed to ramp 3 degrees every 5 minutes, something like that. And this was overnight. So my wife is calling me saying, I'm having contractions, honey. We were probably a week or two from the due date. And I'm like, just hold on to it until tomorrow because I've got to get this part out of the oven. So we still joke about that now, but
Yeah.
yeah,
I'm sure your
yeah,
daughter appreciates that story a lot.
yes, yeah.
Yeah, I didn't have that story, but that work stoppage that I was at, my wife was pregnant at the time, and there was a not an ability, when you're working on the F-22 mod line, phones were certainly not allowed.
Right.
Uh,
Yeah.
I had a pager. So, you know,
So, so was she able to
modern,
page you, or that was
yeah,
that was
shoot.
your backup plan? Yeah.
That was the backup plan. Yeah, I always joke about the pagers because that's how you could tell who was actually on cleared programs. It was this ability to
Yeah.
carry a pager around. So it was like the
Yeah.
1980s called and they want their technology back.
Right. Sometimes it was as simple as call this number and tell this person to go bang on the door. Yeah.
Right.
Remember doing that a few times. Yeah.
So you guys work through that, and then for aspiring founders out there, it's one thing to have an idea. It's another thing to have a permissive environment, let's say, because the support is going to be necessary. And I always, I've now started two businesses, and I always tell people like there are more questions than I ever would have had answers for. Like the questions that come at you are nonstop and infinite.
Yes.
And half the time you're just, yes, yes,
Yeah.
yes, no, yes, yes, no, yes, no. And then, okay, it disappeared for a while and maybe it'll come back. And so I think certainly my wife was very supportive of me going to do something different. That was, as I always say, the universe told me to go do this. In retrospect, yours seems like a very logical progression.
It seems like it felt like I was doing it a little bit late in life. So I started it when I was like 39 going on 40, which is not it's not the kind of model that we all see on, Netflix documentaries and stuff, right? Maybe it didn't make for good reality television starting a business at 40. I do think I probably would not have been successful if I started 10 years earlier, just
Hmm.
because, there's a lot you have to know and, your network becomes hugely important. And I know you know this, John. I mean, just the fact that like you stopped what you were doing and you tracked me down and engaged in this conversation. And I think if I can just really quickly jump over again to advice to younger engineers, when you're in high school, when you're in college, go ahead and create a LinkedIn profile and anybody you work with. And I tell people, find somebody who's doing something you think is interesting and hit them up on LinkedIn. I occasionally get these messages from people who are 18 thinking about a career in aerospace. I cannot resist talking to that person. I'm sure you're the same
Yeah.
way. So like, don't be shy. Ask for advice. People who are in the second half of their career like us, we're happy to give it. And I think LinkedIn is an amazing tool that didn't exist when I was a kid. So I didn't grow up around aerospace engineers. I really didn't grow up around engineers. And so, yeah, definitely leverage that.
Yeah, I agree with that. My daughter was at an admitted students day for well, she's going to go to Purdue in the fall. And one of the things the students said was, have that LinkedIn profile because you'll meet somebody and just, they have an industrial roundtable. It's a big fair. And so resumes and business cards, may be useful,
Yeah.
but you'll have a conversation, we might be there one year and you might be a freshman. We're not recruiting freshmen, but
Hmm.
and we may leave and change businesses. And so, but LinkedIn provides that sort of connective tissue. So I do think that again, we're not a paid LinkedIn paid nothing for this
Yeah.
promotion, but it is important. There's a fine line between sort of being annoying and just being curious. And
Yes.
so I have always told people always be curious.
Yes.
That's perfectly fine.
Yeah.
And because you never really know where that's going to go. So you started Blue Force. Yeah, tell us a little bit about the early days of that. I mean, it sounds like you had a pretty well-formed premise. I mean, you were sort of creating a business segment in a way.
Right. I was trying to hybridize, I think, between the pure prototype shop and the shop that can go to production with you, right? I was trying to hit that gap of we'll get you from one to 100. We might not get you to 1,000. We did have programs where we were doing CNC machining where we did get into the thousands of parts. But, in general, like our huge value add was in the engineering heavy prototyping into kind of low rate production. So I think in hindsight, it was a decent business model. I definitely, I did not raise a lot of money around it. So I definitely went into it kind of undercapitalized, which meant that we basically had to find work the whole way, right? So, 2 or 3 months in, I got my first paid contract with Boeing, with BR&T building Chinook parts. And Boeing at that time was really fascinated with out of autoclave composites.
Yep.
And I don't know what your experience is with out of autoclave composites. I always thought it was funny because it's like saying I drive to work out of Ferrari. Like I don't have a Ferrari, so I never would think about driving a Ferrari to work. So if you're asking me to come to work, fine. So I kind of felt like out of autoclave composites was like we didn't have an autoclave that scaled. I sure as heck wasn't going to buy an autoclave at Blue Force. When I worked at Gulfstream, we had autoclaves, but I would basically like not let my team use the autoclave, because I did not want to become reliant on an autoclave. We helped Boeing develop basically an out of autoclave process that gave autoclave equivalent mechanical properties, which, when you're at a big company or anybody who's certifying an aircraft, ultimately you have to develop what are called B basis
Hmm.
material allowables because that's what the FAA wants to see, which means you've done multiple batches. The process is robust. You've characterized all these different mechanical properties. And John, as you know, I think a B basis program, they used to say it cost $1 million, but it's more than that now. So Boeing, I think with some Army money was developing these out of autoclave processes. And so we were the perfect shop to help them with it because we were not a shop with an autoclave that said, yeah, yeah, we're gonna not use the autoclave. We were a shop that like had
Hmm.
no vision of getting an autoclave. And ultimately that led to us winning a production contract with Boeing. So, and the Anduril team, they're still building parts for Boeing on those contracts to this day. So it was kind of again proof, and I would imagine the part counts are in the hundreds by now. So it was proof that a small business, if you establish good process control by implementing a quality management system early, you can grow into doing things that you might have thought that only big companies could do.
Yeah, well, I will say it's hard to shove a QMS into a mature system. It is easier. We're kind of living through this now, but my co-founder Chris had a QMS in mind the entire time, so knowing we
Yeah.
needed to do that. But kind of picking up on what you just said, so I think a lot of people don't really understand how I'll say the defense industrial base actually works. There's the primes and love them or hate them,
Hmm.
they fulfill a certain role. But my role at Lockheed Martin was even with Skunk Works was we dealt with I had to go deal with companies like yours, and it was always fascinating and amazing because I worked with a bicycle manufacturer because they had special welding and forming technology.
Hmm.
They were making titanium bicycle frames that were bespoke, and so we needed some help in that area. We worked with a surfboard manufacturer, which was what now we know as JASM, which is the sort
Mm.
of low
Yeah.
observable cruise missile. We even worked with the high performance kite manufacturers for those textiles in the
Hmm.
kites for P791, which was an airship. It's hard to imagine a flying wing concept of an airship, but I'm told that it had some lift associated with it when it
Yeah.
moved at its dash speed of 35 knots. So having access to your shop, there aren't a lot out there. I mean, Scaled formed some version of that, but like first or second to does it become a program? And then you kind of have to go through these things, a lot of which is characterized in that valley of death period, which is the customer going to buy this product? And we need to go from 1 to 10 to hopefully
Hmm.
something greater than 100. It just seems like it's lost on a generation that there is a dependency, with the industrial base because there's all these very specialty things. So, like you
There
mentioned, an
are. Yep.
autoclave is not something
Hmm.
that everybody's going to have. Even if you don't
Hmm.
like autoclaves, at some point, the technology it represents has to be replaced by something else. And of course, yes, the out of autoclave. And now I'm remembering all of the terrible acronyms that we had,
Yes. Yeah.
Vardum and all of these
Yeah.
things. So yeah,
But
so so
to really quickly tie it back to like what our value was as a business and the quality system, when Boeing wanted to figure out how to make parts out of autoclave, of course they had made some coupons, so they knew what their material system was they wanted to use.
Mhm.
They were ready to go to the part level. And so we came in, we tooled it, and we built one part 7 different ways. And so that meant I had to write 7 unique work instructions that captured every detail. And if you're not familiar with composites, like the devil really is in the details with composites. Sometimes like the film adhesive has a poly side and a paper side, right? The material that prevents it from getting contaminated. And so, which side did you put up? Did you put the paper side up or the poly side up, right? Things like that matter. And so unlike a lot of small businesses where they would just throw a guy at it and get the part made and hand it to you, we believe that our delivery was knowledge capture, right? That was our deliverable to you as a customer. Whether the part worked or not, you would determine that through testing or whatever, but we could tell you each serial number part exactly how it was built. And I think that is where like process control at a young age in the company was really important to us. You shouldn't have a different way of running the oven every time. You shouldn't have a different,
Yeah.
you need to nail these things because if you make a beautiful part but you blow the oven cure, a couple times in a row because you were just it was written on a post-it note or whatever. You're living up to the stereotype of a small business. And you were talking about going to small businesses, and I was thinking, I'll bet the thing that would most assure you when you went into a small business to work with them is whether or not they had some sort of quality system. Whether it's ISO or AS or whether it's just 80% of the way there, are they writing stuff down? And those that aren't, it's like beware, right? Everything
Hmm.
becomes a stunt.
Yeah, I did an interview on this podcast probably a year or so more. There's Paul Gradle works for NASA Marshall, and he always refers to a repeatable, reliable process.
Yes, yeah.
So it doesn't really matter what you're making. Your process needs to be repeatable and reliable.
And in the beginning, guess what? It won't be. But if you're not taking the data along the way, it never will be. And so, you're basically paying tuition, right? Every time you build a part, a composite part can be worth anywhere from 10,000 to $1 million, right? So if you're putting $1 million in the oven, you need to know whether or not it worked. And the way to do that is to capture all the processing that went into it and then evaluate it on the back end and tweak your process. Otherwise, you're just lost in the wilderness forever. If
Yeah.
nothing's repeatable, you're not going to get very far.
Well, you mentioned like $1 million for the allowable. I would say that's just for the allowables. Like getting to
Right.
the point of mapping your process to know that you can even be.
Right. But yeah, I mean, on the way to building a wing skin, for example, you put a wing skin in an autoclave, that's $1 million right there. So if something
Yeah.
goes wrong in the autoclave, you could be throwing away $1 million. That's not fun. Process control all along the way is important. And I think,
Yeah.
for us, our quality system underscored that. And if you don't mind, I'll go into that a little bit.
Sure.
Because I think the way we did it was unique. I mean, I certainly had a lot of auditors scratch their head and tell us it was unique. They always approved us because we weren't doing anything wrong. But I had spent a lot of time working with companies where I noticed that if they had a quality system, they would spend a lot of time trying to figure out how to get around it every time there was a defect, especially on a rapid program. So it's like, oh, can we call this a pickup instead of a nonconformance? And so I realized like the quality system needs to be really flexible. So I created one and I wrote it myself. First I got a copy of somebody else's and I thought I'm just going to put Blue Force on this. And I read it and I'm like, oh my gosh, this is terrible. This will bankrupt us. So I completely rewrote it from scratch. It was actually while I was home after my wife delivered our third kid. So I told you she was pregnant. So, was kind of home on for a couple of weeks trying to help out with changing diapers and at the same time wrote our quality management system. So we literally implemented it the day I hired my second person. I hired a gentleman to be my plant manager, and then we got our audit the day after that, right? So we were two
Wow.
people, two people sitting across from one person at a folding plastic table. And he was like, okay, this is interesting. I've never done this before. But to his credit, like we went through the standard line by line and showed that we had been doing work on work orders and we had process control and we had training records for all of our employees and all that. And
Yeah.
so that allows us to grow from there. But the important part was we wrote it the way we wanted it to be. And I told people, this is our constitution. We're going to follow it. And if we don't like it, we're going to change it. And so, probably by the time I left at year 10, we were on like Rev I or J of the basic manual. And then each of the sub processes was a standalone document, and we would have different process owners who could change that. But it worked really well for us. And we never had a QA manager. We never had a quality
Wow.
department. Okay, so we did all this by using basically, I would call them like interlocking inspections, meaning if the engineer writes in the work order that I want to do a leak check after I've bagged the part before I put it in the oven, very standard thing to do. Who can inspect the leak check? Well, let's get another technician to do that. So if you were at a certain level in your training records as a technician, you could go do a leak check for somebody else. That's a very simple example. But, so people were amazed when they would come in, especially when we got to NADCAP, which is kind of like a whole new level of
Yeah.
process control. The NADCAP guy was like, you should write a paper on this and present it at like a quality conference. And I was like, this is our secret sauce. I'm not sharing with anybody how we're doing this.
Yeah, it's interesting. It seems like at times there now it's the process needs to reflect the requirement. The process
Yes,
doesn't guarantee you that you know what you're doing. In other
right.
words, you're not there to be captive to the process. The process is there to help your life become easier.
That is a great point. And one of the things we put in our QMS is that we were a project organized company. So when we're working for Boeing on I can't remember what the Boeing process number was, but basically, we used an out of autoclave deviation to their autoclave manufacturing spec for composites. As you can imagine, that document plus all the documents it referenced probably totaled to 2,000 pages. That project had to understand that and use it. That doesn't mean that if I'm doing a quick one-off prototype that's going to be an FAA experimental for somebody else, I don't need to use that. So we had some common processes, like here's how we're going to vacuum bag a composite part, and then each project could tailor that as they needed. And so yes, your point is so correct. Like you do not want the process to drive how you do business. You're fundamentally you're doing business to add value by either capturing knowledge or delivering somebody a conforming part and understanding what they value and putting that into a project with a charter, right? Each project had a charter. We said like, who's doing design reviews? Are we doing design reviews? Are you doing design reviews?
Mm.
Who has stress analysis responsibility? So we very, very clearly spelled this out in the beginning what the rules of the road were. And then that charter would kind of lead us through the rest of the design and development process. Because unlike most small businesses try to get an exemption for design within AS 9100, and we left design in there. So we were a full AS 9100, design and production kind of shop.
I think what we see on the with TBGA, we help a lot of
Mhm.
companies with advanced manufacturing stuff. A lot of it's additive manufacturing, and
Mhm.
so the process of qualification is the process. It doesn't
Mhm.
matter what process you're using. The details are different. But I think that what we found is most of us come from primes and tier one suppliers. So it's that intent versus box check. Like there,
Yes.
if you
Yeah.
understand the intent behind allowables and the quality system and the design process, it's much easier to figure out a path than, oh, I've got a checklist and I'm just ticking boxes off. The box checking doesn't guarantee anybody of anything as far as I'm concerned. If you don't understand the intent, then you're really just it's a very superficial activity.
And I think you're hitting on something really important, which is sort of culturally the death of companies when the process takes over, and especially when the engineers are not allowed to deviate from the process for fundamentally sound reasons. And I'll give a good example. I won't name the company because I don't want to embarrass them. But we went through qualification with a company. They actually gave us a Supplier of the Year award, so we were a really good supplier to them. But they had this crazy holdover from the autoclave, which is that you had to let the oven temperature get down to 100 before you could take the part out of the oven. Well, we're in North Carolina. We had an unair conditioned shop. Our clean room is air conditioned, obviously, but where the oven is not air conditioned. So the ambient temperature could be 95. Well, that means the oven will never get to 100. We'd literally stick an air conditioner in the oven just to meet the spec. And one time they came to us and said, like, hey, what are some things you're doing that are dumb and, cost us extra money? And we're like, well, this is a good one. And we went round and round for months over this particular one, and they would not take it out. And I was like, guys, your spec says I can get the oven to 140 and do an oven abort. In other words, I'm not holding vacuum. I don't like what I see. I can shut the oven down. I can take the part out at 140. I can fix whatever went wrong. I can put it back in the oven and start the process again. It doesn't even give me a number. I can do an infinity number of oven aborts at 139.9. So why the heck can't I take the part out of the oven before 100, right? Nobody could answer that other than we don't have test data showing it's good.
Yeah.
Move along, right? And I think this is culturally the death of companies, and it's kind of the spiral that big companies get into, where instead of the engineers being able to apply first principles, they just interpret the spec in the strictest way possible.
I was at an event in February and we met a group captain in the RAF. We were talking about being able to use new processes and stuff. And he goes, well, the difference in the RAF is we're much smaller and anybody you deal with, whether an aircraft is airworthy, is an engineer. So I,
Mhm.
as an engineer, can go to the group lead and say, can I put this part on your airplane? And I was like, you don't have a SPO? Like, what?
Right.
So I don't
Yeah.
know. That part to me was fascinating.
Yeah.
In our prep talk, we had talked about, I think this is an important point too, that this is advice for the younger engineers. We had a conversation about what failure means. And yeah, I think to unless you remember exactly what you said, but failure in your mind was something to the effect of when you don't know how you made it, and
Right.
it's really that knowledge capture piece. I had an experience where I went to an innovative supplier, and they had this very elaborate check-in process to get into their development lab, and the reason for it was is they had an engineer go in, didn't write anything down, got the best results they ever got, and they have never got them again. Don't know
Yeah.
how they got there. And so
Yeah.
this new process was you had to write stuff down, you had to hand it to a technician, the technician carried out the experiment. And I know that the second part of that story is, that was I was in a meeting once with the Deputy Undersecretary for Industrial Policy, and we were meeting with the head of Skunk Works and his lieutenant. And he's like, we're in Palmdale. He's like, I just went to Boeing. I'm here. Why are you guys different? And they said it in a much more eloquent way, but the fundamental thing was we allow people to fail here as long as they learn from that failure.
Absolutely. Yeah, I used to tell people, we're paying tuition, right? Like that bad part, we just paid tuition. So, please tell me you learned something from it. And it's not just I'm punishing you, please tell me. No, I mean, I literally mean like, can we go through and using design of experiments, can we tease out, which factor you changed that, led to the part not working? Because that's really important. And we used to have a joke like and I think I've heard this elsewhere too. Like we're not the only ones who think this way, but it's okay to make a mistake. It just needs to be an original mistake. Like it should be kind of interesting.
Yeah.
It should be, one time we had a guy drive a forklift at like full speed. He had the forks up and drove it like into the pass through wall and it just destroyed this. And it's like, we really didn't need to learn anything from that. We just need to fire that guy, right? But anything having to do with composites, there's usually an interesting story to why the failure happened, right? Especially with out of autoclave, where out of autoclave is a very finicky process that kind of just barely works, even when it works. And so, just
Yeah.
understanding what that threshold is and being able to improve your process, right? And I think that's where by not having this departmental thinking, by just having like project focused customer success thinking, we iterated our processes continuously.
I want to hit on what you're doing now. I think there's more. We could have a series of podcasts. Maybe we should go find some other people to interview. We can just do that.
Yeah.
But I would, it's important. So you did Blue Force. Now you're doing something else. Again, for people that don't know the story of Fury, I highly recommend that Merge podcast because I thought it was pretty fascinating. As a portion of that, I think for younger engineers, it's important to know what are you designing for. So I
Hmm.
teach a class at Carnegie Mellon once a year, just as a guest lecturer on design for assembly or design for manufacturing.
Yeah.
And so these things do make a difference depending upon what you're trying to achieve. And designing for 10 or 100 or 100,000 is a very different
Yes.
proposition.
Yeah.
So we could probably come back, but this is that system level thinking. Now you're going to do something even more interesting. So you have the DoD Accelerator Fund, and then you also have this new endeavor with the stealthy secret sauce and
Yeah.
clouds of mystery around it.
Yeah. So DoD Accelerator, so my partner at Blue Force, Joe Murray, yeah, when he and I came out of the acquisition by Anduril and we got the sort of integration complete. A few months later, we were having coffee and just kind of reflecting on all the experience. And we realized that we had met a lot of really viable, investable small businesses like Blue Force. And we kind of wanted to put our money where our mouth was and invest in some of these. And then Joe, I think, mentioned like, well, hey, I wonder if we should start a fund. And of course, neither of us knew anything about how to do it other than like people go to jail for doing it the wrong way. So, but
That's
like
always
like
rule number one. Don't go
rule
to
number one,
jail.
don't go to jail. Yeah. And so so Joe had met Mark DiNatale and Vince Gubitosi, who are, just for shorthand, I would call them Wall Street guys. I mean, they basically, grew up in the sort of, I would say, big Wall Street instead of big aerospace. And they had seen where value is created and where it's destroyed. And very much like Joe and I thought, their heart was more in the smaller scale, more bespoke. That's where the actual opportunities are. By the time the $1 billion fund full of dumb money shows up,
Hmm.
it's already the value is already out of it. And so we just had like a natural liking to those guys, and they know how to start a fund and do it legally, register it, all that. And, intentionally, the general partners, which is the four of us, our money is like 40% of the fund. So we're basically very heavily skewed towards we're investing our own money, but we're happy to have a few selected limited partners, come along. And, the limited partners we have are amazing. They are, high achievers in their own right and have a deep Rolodex. So yeah, we started doing this a little over a year ago. We've made three investments and we've got three more in the pipeline right now. They're all pretty exciting companies, but they're all going to be pretty high touch because just like this conversation, if you're a founder doing something in defense, there's no way you can know everything you need to know about, I've got to get a DCAA audit. I've got to get a
Mhm.
security clearance. How do I implement a quality system without crushing my culture? All those things.
How do I get on SAM?
Yeah, how to get
How do
on
I get on
SAM.gov?
SAM if I need a DUNS number, but I need a DUNS number to be,
Yes, all those things. And so we're able to help them through that. One of our companies actually, they've had a heavy surge in demand since this thing in Iran started, and they need some working capital. So we're like, hey, we're going to introduce you to some people at the top tier of a bank that we know. And if that doesn't work, we're going to do a convertible note and just get you the capital you need. So we're kind of like in it with you, in it to win it. If we invest in you, it means we really believe in you, and we're very selective because the current VC model does pretty well serve the, I call it like five guys with a PowerPoint, kind
hmm
of startup. There's a lot of people with big ideas that sound really cool and it feels investable to, I think, conventional VCs. We're not like that because we've been around and we've seen where companies, fail in the defense industry. And I think we're better able to evaluate kind of who has the X factor to make it.
And so, maybe just give us if somebody has an idea or a company, what's the ideal or what's the character of the type of company that you would?
We'd like to see companies that have some operating history. I mean, my favorite kind of company is one that's been around, I would say 2 to 10 years. They have customers, they have contracts. Hopefully, they have some government contracts and some commercial contracts. So they're used to the basics. I mean, getting back to that process thing, right? I mean, a lot of startups don't even know how to negotiate a contract with a customer, how to track your time, how to bill, all these basic things. So I want you to have that out of the way. And then I want you to have seen where you can add value in the system, right? So, if you're a company that's making, a certain type of sensor or transducer that's going into somebody else's product, you might look at that and say, hey, wait a minute, I could package it differently from how everybody's thinking about and just sort of revolutionize some aspect of what the DoD does. And I think Fury is a really good example of that, right? So we had developed our own bespoke manufacturing methods that allowed us to get basically autoclave prepreg composite properties on soft tooling using infusion, right? And so we said, where could we apply this technology? Well, the Air Force and DARPA are talking about spiral design, iterative
Mhm.
design, and frankly, they don't have any UAVs that can do what a fighter can do. So, like, let's kind of go in that direction. And so, Fury was originally meant to be built on soft tooling and built in sort of batches of 12 to 24, right? So a squadron at a time. And if you wanted to iterate between vehicles, I'm sorry, iterate, sort of have model years, we could iterate the design because our aero and our stability
hmm
controls and our flight control system tool chain was really tight, and our investment in the physical tooling was really minimal. And so I think that's an example of where, we were a company that had been in the industry, but we saw a niche that nobody else saw. And so we were well prepared to go after that.
Yeah. And I think it's as you were talking about it, I always think like the C-130, even now today, the KC-135s, the B-52s, like these are old airframes, but
Yeah,
they're big, but they're very adaptable. So that's why you have, I don't know how many variants of a C-130 there are out there now.
right.
But you have real estate basically. You don't, with a CCA, you have no real estate. It's
That's right. I
it's
think
it's pretty
the
small.
Yeah, I mean, my take when we were working with A4L is you will never re-engine a CCA like you're doing the B-52. You'll actually re-airframe the engine that was in the CCA. So, I
Mhm.
had, generations of future designs around the same engine in my sketchbook because, it's very clear to me that like we can design something for a certain capability, but we shouldn't do this exquisite multi-role $100 million CCA thing, right? We should be doing these at like sub $10 million, preferably like $5 million, where it becomes almost a throwaway component.
And
Yeah.
so now you're doing. and now for something completely different, as
Now
I
for
would say.
something completely different. Yeah. Yeah. So, yeah, actually, along the way, I've got kind of always had an interest in farming. And, we picked up a hobby farm back in 2020 when everybody else was doing the COVID, let's do something different with our lives kind of thing. And just through that and through watching how, farming is done, I would say at the smaller scale, I realized there's a lot of farms that have been left behind by John Deere and Case and all the bigs. And so, there's obviously a lot of resonance there with the big primes in the defense world. And so, part of the recognition is that there's some equipment that's missing that would work well at small and mid-sized farms. So, for first time ever saying this out loud anywhere, I've got a new company called TrueField Systems, and we're working on a small harvester. If you go look at combine harvesters, they tend to be anywhere from $700,000 to over $1 million to get into a new one. They're very large machines. They're optimized for, the Midwest where, fields are, half mile by half mile and they work really well there. But that sort of eliminates the ability to do specialty crops at a smaller scale.
Hmm.
And so we're working on both the equipment to make that possible for the farmer, as well as a digital platform to help farmers with that. So really
Wow.
exciting. It is definitely completely different, but we are looking for manufacturing engineers, CNC programmers, folks like that. I don't really have the website up yet, but if you are interested, email me at careers@truefield.ag.
Careers at truefield.ag. Okay. Wow. I
Yeah,
don't know that we've ever launched a company on the podcast. I know
there you
we
go.
haven't. So
Yeah. And this is a defense focused podcast, so we'll see how many people we find who are interested in crossing over. But I think there's a lot of we're obviously going to lean more heavily into automated manufacturing with this. Composites is inherently a high touch labor thing, so I'm excited about doing something where the existing automation tools are pretty well set for it. And I will definitely reach out to you because we're going to have some 3D printed content, and I'm going to be looking to you for
good.
advice, John.
All right. Hopefully you won't need B basis allowables. So
Yeah, no.
well, I think I mean this is we could go on for another hour
Yeah, this has been
probably.
great.
Is there anything we didn't touch on that you wanted to, or last words, or I don't want to put you on the spot.
I think we covered it really well. I mean, I would just make a pitch for engineering and manufacturing in particular that, if you're a young person, there are so many exciting things going on in manufacturing. And I think unfortunately, if you're in high school, you may not have been exposed to it because, high schools, frankly, are a lot of them are more interested in preparing you for college than sort of talking about real world things. But there's a lot of exciting stuff going on in manufacturing, and there's a lot of things that you can be doing at home, between Raspberry Pi if you're a computer nerd, or 3D printers have gotten pretty low cost, are pretty available. I just encourage younger folks to like indulge that creativity, because you can have a fantastic career in manufacturing. You can create a lot of value for a lot of people. You can create a lot of value for yourself and raise a family on the income. So highly
Yeah.
encourage it.
And it's fun to make things.
It is fun to make things.
All right, Scott. Appreciate you being on the show. And one day I hope that we actually get to meet in person.
Sounds good. Probably won't be at Sampi, but we'll find some show that we both go to.
Yeah, sounds good.
Thanks,
All
John.
right, thanks.
Cleared for takeoff.
You've been listening to Manufacturing Mavericks, hosted by John Barnes and powered by the Barnes Global Advisors. Take a moment and subscribe to our channel.